Hello everyone, I am Dr. Abha Kumari. Today we will discuss some more theorems and problem from graph theory. It's a lecture 7. Earlier I have given lecture 6 in which we have discussed the graph of open walk and the closed walk. So today's theorem is a simple graph with n vertices and k components can have at most n minus k plus 1 divided by 2 edges. And I have given a PDF of this theorem. Okay, so just see the second part of this theorem as if a simple graph G with n vertices has more than n minus 1 n minus 2 divided by 2 edges, then G is connected. Fine. So this is very important because the 1 marks question can be asked with this formula. So let us see an example. Let G be a simple graph with 6 vertices. So here the 6 vertices, okay, is given. Here the n vertices, then we have written the n minus 1, n minus 2, and we have here the 6 vertices and 11 edges. Check whether the graph G is connected or not. So to check the connectivity of the graph, we have to find the what relation we will use. So here the relation we will use is n vertices has more than this edges. So this one is very important. We will use this formula to find the number of edges here. So here it's given that n equals to 6, and here n is what? The number of vertices, whatever the given is your n. So n is equals to 6, and we have a formula like n minus 1 n minus 2 divided by 2. So we have put it here 6 minus 1 6 minus 2 divided by 2. By calculating this value, we will remaining with the value 10. Fine. And what we will see in this theorem is n vertices has more than this much edges. Here what we get? 10, and 10 is what? Less than 11. And why 11? Because we have given in the question as and 11 edges. So we have to compare with this number of edge, that is 11. So here we see that the 10 is less than 11. Therefore, according to the above theorem, G is connected. So this is very important. Now next is complete bipartite graph. Earlier we have discussed the bipartite graph. So today we will see what is complete bipartite graph. A graph G equals to VE, number of vertices and number of edges, is called a complete bipartite graph of its vertex V can be decomposed into two subsets, V1 and V2, such that each vertex V1 is connected to each vertex of V2. Suppose we have two sets. Okay, then each one of the set 1 is connected with the elements of the set 2. So here we have taken the V1 and V2 are the two sets, and V1 is connected to each vertex of V2. Suppose we have taken here the number of vertices in V1 equals to m and number of vertices in V2 equals to n. Then the complete bipartite graph is denoted by km, n, okay, and has m plus n, whatever the number of elements here m and n, we will just add this value, then we get the number of vertices, and if we product this value m into n, then we get the number of edges. So if you have given the k to 5 like this, k to 5, and if you have to ask the number question that how many number of vertices, write the number of vertices, then we simply just add this one, 2 plus 5, that is 7. So we have 7 vertices. Fine. And if we will ask for the what is the number of the edges, then we only just multiply this value, so we get the 10 edges. So this is the objective question can be asked in your exams. So here we will see an example. So I have taken the V1 as U1, U2, U3, and V2 as V1, V2, V3, and V4. That is this one is the first set, and this one is the second set. Right. So what we see that each element of the set 1 is connected with each element of the set 2. So first we join the U1 with each and every element of the set. So U1 can be joined like this: 1, 2, 3, and then 4. Fine. Then we will join V2. 1, 2, 3, 4, and then with 3. So 1, 2, 3, and then with V4. So we have joined each and every element of the set V1 to each and every element of the set V3. Suppose we have the set 1 as U1, U2 and U3, and then the set 2 as V1, V2, V3 and V4. Fine. So this will give us a complete bipartite graph. So the question is how many the number of edges and number of vertices here is. So the number of vertices. So what is the number of vertices? U1, U2, U3. Then set 1 we have 3 elements. So 3 plus in the here is 4. So the number of edges is 7. So you see 1, 2, 3, 4, 5, 6, 7. So the number of the vertices is will give us the 7. Next is number of edges. So this is 3 into 4, that is 12. So let us see, we can calculate this one. U1 connected with the 4 elements, U2 again connected with the 4, and U3 again connected with the 4. So 4 into 3, that is we will get the 12. So here we get the number of vertices and the number of edges in this way. Okay, so we will define this complete bipartite graph as K3, 4. Whatever in the left hand side we have the elements, we'll just write this one is in the first one 3, then comma, then 4. So this is the complete bipartite graph having 7 vertices and 12 edges. So next is the question, draw a complete bipartite graph K34. By saying this one K34, what we will understand is that we have 3 and plus 4, that is total number of the vertices is 7. Fine. And total number of edges is 12. So we have done it in the previous one. So let us see some another example. K25. Fine. So let us draw K25. So for the K25, what we will use here, if we will not giving the name, then only we will put the dot here. There's 1 and then 2. Next is a 5. So we'll dot 1, 2, 3, 4 and then 5. Right. Now we have to join each and every vertex this way. All the vertices are joined carefully. This way, join here. Again we join this one, and again then we join this one. So if you want to give the name, then we can say U1 and U2. These are V1, V2, V3, V4 and then V5. So the number of vertices. So number of vertices is how much? 2 plus 5, that is 7. And the number of edges is 2 into 5. This is 2. Okay. Thank you.